magnetic effect of electric current, if you take a wire and allow electric current to pass through it, there is a wire here, and through this wire an electric current is passing. This is open circuit, now it is closed circuit. Current is flowing. So when the current flows from positive to negative terminal. This direction, this is the direction of the flow of current. So current is flowing here. So when current is flowing in this wire, then what happens? Then at any place here, you see the magnetic field, you keep a magnetic needle here close to it. So there's deflection in the magnetic field when the current is passed. Okay. So when current is passed in the wire, then magnetic field is generated in this wire. When current is passed in the wire, then magnetic field is generated in this wire. Okay. This experiment was done by, first of all, by a scientist named Orsted. So it is called as Orsted experiment. So Orsted experiment states that when current flows through a conductor or a wire, then magnetic field is generated around the wire. If you take a cardboard piece and sprinkle iron filings on it, the small pieces of iron, that's called iron filings. So if you sprinkle iron filings on it, then there you see circular rings will be formed. Circular rings will be formed, right? And these circular rings, they show the direction of the magnetic field. They show a magnetic field is generated. So Orsted experiment says when current is passed through a wire, then magnetic field is generated around the wire, and this magnetic field is circular in nature, and its point of production is the wire, the center of the wire. From there, this magnetic field is produced. This magnetic field, its strength depends on the current, how much current is flowing in the wire. So this was given by Orsted and is called as Orsted experiment. So Orsted experiment states when current flows through a conductor or a wire, a magnetic field is generated around the wire. This magnetic field is directly proportional to the current flowing through the wire. The second thing is the direction of the write down in your notebooks. Magnetic effect of electric current. Write down heading. Magnetic effect of electric current. Write down. When current flows through a when current flows through a conductor or a wire, when current flows through a wire, when current flows through a wire, and a magnetic needle is kept close to it, Magnetic needle is kept close to it. Then as the current is switched on, then as the current is switched on, magnetic needle shows deflection. Magnetic needle shows deflection. It means when current is passed through a wire or a conductor, magnetic field is generated. Magnetic field is generated around the wire. Magnetic field is generated around the wire, which is given by which is given by right hand thumb rule. Right hand thumb rule. Full stop. Next line. Right hand thumb rule states right hand thumb rule states right hand thumb rule states if we keep the fingers of our right hand together in a position such that in a position of showing thumb or in a position such that thumb points separate from the curl of the fingers, separate from the curl of the fingers, full stop. If thumb points towards the direction of the current, like this way, you can see thumb points towards the direction. This is the thumb. Thumb is pointing upwards towards you. Thumb points towards the direction of the current. Then the curl of the finger, this direction, this is the curl of the finger. The curl of the finger. Then the curl of the finger points towards the direction of the magnetic field. So the thumb points upwards, then the magnetic field will be in this direction. Okay, this is the direction of the thumb, and this is the direction of the magnetic field. Okay, so then the curl of the finger points towards the direction of the magnetic field. So current passes upwards, then in this direction the magnetic fields will be generated. Right? So current is upwards, the magnetic field is in this direction. This is called as Orsted. This tells you the direction of the magnetic field. This tells you the direction of the magnetic field. Okay. So I repeat, when current is passed through a conductor or a wire, a magnetic field is generated around the wire, which is given by which was found by Orsted and is called as Orsted experiment. Full stop. The direction of the magnetic field is given by right hand thumb rule, which states that if the thumb of the right hand points towards the direction of the current, then the curl of the finger points towards the direction of the current. Then the curl of the finger points towards the direction of the current. Okay, this is Fleming's left hand rule. And this is given by right hand thumb rule, and this experiment is called as Oersted experiment. Okay. Next, you see if there's a current flowing through a conductor, right? If the current is flowing through a conductor and the conductor is kept in a magnetic field, then a force acts on the conductor. I repeat, if the current flows through a conductor, this is a magnetic field, say this is the magnetic field. Magnetic field is represented by B. B is the representation for magnetic field. And if a current wire, that is wire through which current passes, is kept in this magnetic field, then a force acts on it. So this is the direction of the current, this is the direction of the magnetic field. Say both of them are perpendicular. B is in this direction, I is in this direction. So a force acts on it, which is given by Fleming's left hand rule. Which is given by Fleming's left hand rule. Okay. It says this if this is the direction of the magnetic field B, this is the direction of the current, then I is what perpendicular to this. Fleming's left hand rule, if you see, this is here. Fleming's left hand rule says, say, you can see here this hand, left hand, mine left hand, and in this here, you see the first one. This is the called forefinger. It is pointing towards the direction of the current. These three fingers, they are pointing towards the direction of the magnetic field. Then the thumb will point towards the direction of the current. This is called Fleming's left hand rule. I repeat, this is here. You can see this is forefinger pointing towards the direction of the current. These are the remaining fingers pointing towards the direction of the magnetic field. Two are there, both of them are perpendicular to each other. And this is the thumb, which points towards the direction of the force acting on the wire. So if this is the direction, this shows the direction of the current, this shows the direction of the magnetic field, and this will show the direction of the force. This is called as Fleming's left hand rule. Okay, Fleming's left hand rule. All three are perpendicular to each other. This is the direction of the current, this is the direction of magnetic field, this is the direction of the force. Okay. So note down Fleming's left hand rule. Fleming's left hand rule. If we stretch our fingers, if we stretch the fingers of our left hand, if we stretch the fingers of our left hand in such a way, in such a way that the forefinger, for that the forefinger, comma, rest of the fingers, rest of the fingers, and thumb are perpendicular to each other, are perpendicular to each other, full stop, if the forefinger points towards the direction of the current, if the forefinger points towards the direction of the current, the remaining fingers in the direction of magnetic field, the remaining finger in the direction of magnetic field, then thumb points towards the direction of the force. Then thumb points towards the direction of the force. This is called as Fleming's left hand rule. This is called as Fleming's left hand rule. Okay.